Hi, we're going to look at some examples of using this idea that's here in this picture. So we'll talk about that a little bit to find the average value of a function on a closed and bounded interval from a to b. Okay, so over here on the picture, there are a couple different regions shaded in slightly different colors here. So one of the things important about this picture is that you should recognize that for the function y equals f of x, if I write this integral from a to b of f of x dx, that gives the area under that curve, y equals f of x curve, and above the x-axis from x equals a to b. So that represents the area under that blue curve down to the x-axis from x equals a to x equals b. And then also on this picture, though, we have this rectangular region. And so we have this rectangular region. We could describe the area of that rectangular region as just height times width. So height of that rectangular region, we've got a point labeled x equals c, and the height of that function would just be f of c. So that's the height. And then the width would be the distance on the x-axis between a and b. So that would be b minus a. And there's a theorem called the mean value theorem for integrals that says that if your function is continuous, then there is a point, x equals c, in between a and b, at which these two areas are equal. These two areas are equal. Mean value theorem for integrals. And what we're going to use today is a slightly different version of that theorem. We are going to be finding the f of c value. So we're going to take this relationship here and divide through by this 1 over, divide through by b minus a. So we'll write that as 1 over b minus a times the integral from a to b of f of x dx. And so we're finding that f of c, or that height of that function in this picture. And that's called the average value of that function f of x on the interval a, b. And so in this picture, it's an actual height, the height of the function, right there, that f of c is what we're going to be finding. All right, average value of the function on that interval. So in this picture, it's actually height because the function is above the x-axis. The example we'll look at, though, where we actually use this, our function will also have negative output values. So we'll need to be careful to talk about that not just as average height, but as average value of the function on the interval. Okay, so we're going to just look at an example using this. All right, so we're going to find the average value of f of x equals sine of x on the interval from negative pi over 2 to pi. And you don't necessarily have to draw a picture of this in order to answer this problem, but I'm going to draw a picture just to make sure that we are clear about what it is we're finding here. All right, so we all know what a sine wave looks like. I'm only really interested in the part here from x equals negative pi over 2 to x equals pi, so I'll just draw that part of it here. All right, so we know we've got about from 0 to pi here, and we know that that height is 1, half a cycle of that sine wave over here. And then on the left side of the x-axis here, x equals negative pi over 2, that's when the sine function is at negative 1. So we are interested in the average value of the function on this interval. So we've got some negative output values here. Okay, so really you can solve this problem by just remembering this formula and doing this calculation, but we'll make sure we connect it back here to the graph so that we're clear about what that answer means. All right, so the average value of this function on this interval, our function is continuous, so we should be able to do this. And I just need to set this up here. So I'm just going to say here average value of f equals 1 over, okay, our b is pi minus our a is negative pi over 2. So I'm going to have to be a little careful there with the minus negative. And then I'm going to integrate from a to b, negative pi over 2 to pi, and then my function. sine of x dx. All right, so I just need to evaluate this integral, and I have the answer that we're asked to find here. All right, so pi minus negative pi over 2, I'm going to make that plus, and pi plus pi over 2 is 3 pi over 2. So just doing a little scratch work there. Pi plus pi over 2 is 3 pi over 2. Since I have 1 over that fraction out front, instead of writing it as 1 over a fraction, I'm just going to write out front the reciprocal of this fraction. So we will have 2 over 3 pi. Okay, so that's my expression out front, my 1 over b minus a. And then here I need to evaluate this integral. So antiderivative of sine is negative cosine. And then I'm going to have that function evaluated from negative pi over 2 to pi. So I just use fundamental theorem of calculus, antiderivative, evaluated from a to b. All right, so now I just need to plug in my values here, negative pi over 2 and pi in the right order, do the subtraction, and I'll have my answer. Okay, so the upper limit of integration goes in first, capital F of b, negative cosine of pi, and then minus negative cosine of negative pi over 2. Okay, so these are special angles. We know the cosine of negative pi and the cosine of pi over 2. I have another plus and negative here that I can just change to plus. But all right, so cosine of pi is negative 1. So I'll have 2 over 3 pi. And then negative of negative 1, we'll make that just positive 1. And then plus cosine of negative pi over 2 is 0. Okay, so when I simplify that, I just get 2 over 3 pi in exact form. Or if I want a decimal approximation, I can plug that into my calculator and get a decimal approximation for that. Approximately 0.21. Approximately 0.21. Okay, so what that means in terms of my graph is that just like the graph that's in the picture over here, I can find the average height, or in this case, average value of the function on that interval. So at about 0.21, if I drew a line all the way across here, and I looked at the height of that function at about 0.21, and I multiplied that by the width of this interval from pi to negative pi over 2, that is 3 pi over 2 is the width of that interval, that the actual area of this rectangle, this part here, actual area, f of c times the width times the b minus a, would be the same as the value of that integral on that interval here. So it's describing what we started talking about over here. We're just finding that f of c, what is that height at which the area of the rectangle that we see, signed area, if we have negative function outputs, is equal to the area or signed area under the curve where we have the function f of x from a to b. Okay, so you should probably try some homework problems finding average value of a function. The main thing is to remember this formula that you need. Setting up the picture and kind of thinking about what your answer means is helpful as well. But you don't have to draw a picture every time as long as you remember the formula to use here for finding average value of a function on an interval. You can do all your homework for this.